Hi everyone, welcome to my video. Let's explore black hole information paradox today. First, let's know about what's a black hole. A black hole is reproduced by a supernova. It has infinite density and infinite mass. Its very big gravity doesn't allow anything that's slower than the light speed to escape from it. A black hole has two main parts. First is ergosphere. So ergosphere is the energy layer of a black hole because there are many stars uh, spinning around the black hole because it's very big gravity. So that causes a black hole has a very big energy. And the other part of a black hole is horizon. So in the horizon, we can't see anything because it's absolute vacuum. So it's absolute dark. According to Werner Heisenberg's uncertainty principle, there will be virtual particles for no reason around a black hole, like this. So they are virtual pairs. The virtual pairs move too fast to be detected, and once they get close to a black hole, one of them will become positive particle, and it has positive energy, and the positive particle will go up, and the other one will become negative particle, and it fall down into black hole and never goes out. As we see this process from our macro world, the black hole is releasing its mass and is evaporating and finally disappears. So this process is called Hawking radiation. Entropy has many definitions in science, but in this case, it's the measurement of randomness. The measurement if there are more stars here, the entropy will become bigger because there are more informations here. The entropy is always increasing because our universe is still expanding. So the space information will become more and more random, and the information will become bigger and bigger. And it's hard to describe the situation. So the entropy is always increasing. And the other physics law is energy conservation law. Energy conservation law. So this law tells us the energy can't be destroyed, and it will not increase or decrease for no reason. Like if I release a ball from here, and it will goes back and forth, back and forth, back and forth. So in this process, the energy, the potential energy here is the maximum. And as it moves, the kinetic energy will become bigger and bigger. At this point, it's the maximum kinetic energy, and also it's the minimum potential energy. So when the potential energy become bigger and the kinetic energy goes slower, but the total energy, the energy total in a closed system is always it never change, so keeps the same. But why the war it will finally stop here? This is because the air resistance transform uh, the kinetic energy into internal energy gradually, and the internal energy will become the object that dispose heat. The heat cannot be used to move the wall. So when all the kinetic energy has been transformed into internal energy, nothing can be used to move the wall. So, but the energy is still conservative. But why we mention these two laws in our video? This is because the Hawking radiation seems to break these two laws. Hawking radiation is a quantum process. This means the output information may be not the same as the input information. Like imagine if we put our Earth into the black hole, and as the black hole is evaporating, and some the particles of our Earth's information will become positive particles. It goes out, but the particles goes out doesn't match the informations we put in. Probably we may lose some mountains and some countries or other anything you can imagine. So it's very interesting and a little scary. But where do the informations, the entropy, and the energy go? So that causes a very big paradox. So that's black hole paradox. And what's the best solution today? And what's the black hole war? Let's explore in our next video. Thank you for watching. Goodbye.